And now I want to look at examples on sum and difference identities. But then before we proceed, let's write out all the trigonometric identities we have acquired or learned so far. The first one were the first three we learned, that sine square theta plus cos square theta is equals to 1. Similarly, when we divide all through by sine theta, we'll have that 1 plus cot square theta is equals to cosec square theta. If we divide the first expression by cos square theta rather, we will have that tan square theta plus 1 is equals to sec square theta. Now, moving on, let us now remember or remind ourselves the values, the expressions on the sum and difference identities. Those ones we learned in the last video, last lesson. So we have sine A plus B to be equals to sine A cos B plus cos A sine B. Similarly, we have sine A minus B to be equals to sine A cos B minus cos A sine B. Moving on to cos A plus B, we will have it to give us cos A cos B minus sine A sine B. In advance to cos A minus B, we will have it to give us cos A plus cos A cos B plus sine A sine B. And moving on to tangent, so we have tan A plus B, tan A plus B to be equals to tan A plus tan B, okay, divided by 1 minus tan A tan B. Interestingly, we'll move to tan A minus B. So tan A minus B will have tan A minus tan B divided by 1 plus tan A multiplied by tan B. The three fundamental identities, and we have 6 identities that talk about the sum and difference identities. Now, when do we apply the sum and difference identities? We apply them when we have compound angles. Okay, now what do we mean by compound angles? Compound angles mean where we have two special angles being added or subtracted together. So in this case, we recall this from lesson 22 where we dealt with special angles. We have sine theta, cos theta, and tan theta of 0 degrees, 30 degrees, 45, 60, 90, 180, 270, and 360. Well, these are the special angles we know. So if we are asked, for instance, to evaluate sine 75 degrees, sine 75 degrees is a question on sum and difference identities. Now the question is, what will be the two things we add together or that will subtract together? So what will be these two things that we add together, or what could also be these two things that will subtract together that will give us 75 degrees, considering the special angles that we have. Now if we take a look at this now, we can see that when we add 30 degrees and 45 degrees together, we will have 75 degrees. So we are saying that A is equals to 30 degrees. We can use A to be 45 degrees too, and B is equals to 45 degrees. And if we interchange it, we will arrive at the same answer. So what we are saying now is that sine 35 degrees or sine 75 degrees is equals to sine 30 degrees plus 45 degrees. Now to simplify this, we will have to recall the formula of sine A plus B. So if we recall vividly on sine A plus B, we will have that sine A plus B is equals to sine A cos B plus cos A sine B. So sine A plus B is equals to sine A cos B, okay, plus cos A sine B. So in that case, sine 30 plus 45 degrees, so 30 degrees plus 45 degrees is equivalent to sine 30 degrees multiplied by cos 45 degrees, because A is 30 and B is 45, plus cos 30 degrees multiplied by sine 45 degrees. So in view of this, let's look at the table and finalize the example. Sine 30 degrees is 1 over 2, just as we have here, sine 1 over 2. And cos 45 degrees is root 2 over 2 multiplied by root 2 over 2 plus cos 30 degrees is equals to root 3 over 2. So we have cos 30 degrees root 3 over 2, and sine 45 degrees is equivalent as root 2 over 2. So this will be multiplied by root 2 over 2. So if we simplify this further, we will have this to give us root 2. Okay, root 2 divided by 4. And similarly, we will have this to give us root 3 multiplied by root 2 divided by 4. And if you apply the rule of sorts, because in sorts we understand that root a b is equals to root a multiplied by root b. So applying the rule of sorts in this case, we'll have that root 2 multiplied by root 3 will be equals to root 3, or as the case may be, root 3 multiplied by 2 divided by 4. So with respect to this now, we'll have root 2 over 4 plus root 6 over 4. Factorizing with 1 over 4, we have this to give us root 2 plus root 6. So this is an expression for sine 75 degrees, which is equivalent to sine 30 degrees plus 45 degrees. So now we can see the interesting part of it, where we evaluated this without tables or calculators, where we used a and b and the formula sine a plus b. Let's proceed further, and now let us take another question 2, and say we want to evaluate cos 15 degrees. Cos 15 degrees. We are going to ask ourselves, what are the two things we will add together, or the two things we will subtract together to get 15 degrees from the tables of special angles. Now, if we take a close look at this now, to get 15 degrees, all we can do is to subtract 30 degrees from 45 degrees. So we are saying that 15 degrees is equals to 45 minus 30. So we are using the subtraction or the difference formula of cosine. So we are saying cos A minus B, where A is equals to 45 and B is equals to 30. So we are saying cos 15 degrees is equals to cos 45 degrees minus cos minus 30 degrees. Now, since this is a different formula for cosine, all we just have to do is go back to our identities and pick a formula for cos A minus B, which is cos A cos B plus sine A sine B. So let's write it together, and we remember that cos A minus B is equals to cos A cos B minus sine A sine B. It should be plus sine A sine B. So let's simplify further. We understand that A is equals to 45 degrees and B is equals to 30. Therefore, we are saying that cos 45 degrees minus cos minus 30 degrees, where A is 45 and B is 30. This will result into cos 45 degrees multiplied by cos 30 degrees plus sine 45 degrees multiplied by sine 30 degrees. Now, to get all these special angles, we go back to the table and we see that sine 45 degrees is root 2 over 2, cos 45 degrees is root 2 over 2, sine 30 is 1 over 2, and cos 30 is root 3 over 2. So using those four answers, let's simplify further. So cos 45 is root 2 over 2, cos 30 is root 3 over 2, and we have sine 45 also to be root 2 over 2, and sine 30 to be 1 over 2. So simplifying further, according to the rule of sorts, this will result into root 6, just as we had in the last example, over 4 plus root 2 over 4. and we factorize with 1 over 4. We'll have this to give us root 6 plus root 2. And this is an expression for cos 15 degrees. Now we are saying something special, that cos 15 degrees is equivalent to sine 75 degrees. Okay, and this shows that these two angles, they are complementary in nature. It follows the law that sine theta is equals to cos 90 minus theta, and likewise cos theta is equals to sine 90 minus theta. So we are saying that sine 75 degrees, we will follow this, sine 75 degrees will be equals to cos 90 minus 75 degrees, and this is equivalent to cos 15 degrees. Now we can see how the trigonometric identities that we have been evaluating now have been syncing with each other. Now let's take one more example before we call it a go on this lesson video. That's question number 3. We're asked to simplify cos 105 degrees. The question now is, what are the two angles we will add together, or what are the two angles we will subtract together from one another to get 105 degrees? Let's go back to our trigonometric special angles table, where we'll have 60 degrees, 90 degrees, and we are looking for 105 degrees. So if we look at it, 90 degrees minus 45 degrees is equivalent to 45 degrees, which doesn't work. But if we add 45 degrees and 60 degrees, we will have 105 degrees. So that means the two angles we are adding together is 45 degrees, 45 degrees, and 60 degrees. So in view of that, we have cos 105 degrees we have that cos 105 degrees is equals to cos into 45 degrees plus 60 degrees. Now to simplify this further, we'll recall the formula on cos A plus B. Cos A plus B, what we did before now was cos A minus B. Now if we look at this now, cos A plus B is cos A cos B minus sine A sine B. So we have cos A plus B to be equals to cos A cos B minus sine A sine B. So let's simplify now, where we'll have cos 45 degrees minus plus 60 degrees. We understand that A is 45 degrees and B is 60 degrees. So this means we have cos 45 degrees multiplied by cos 60 degrees minus sine 45 degrees multiplied by sine 60 degrees. So in view of this, let's go back to our sine special angles table. Sine 45 degrees is root 2 over 2, sine 60 degrees is root 3 over 2, cos 45 degrees is root 2 over 2, and cos 60 degrees is 1 over 2. So imputing that into what we have here, cos 45 degrees is root 2 over 2, and cos 60 degrees is root 3 over 2, sine 45 degrees root 2 over 2, and sine 60 degrees, or 60 is 1 over 2 rather, cos 60 degrees is 1 over 2, and sine 60 degrees is root 3 over 2. So with this, we simplify further according to the rule of sorts. This will give us root 2 over 4 minus root 6 over 4. So if we simplify now, we'll have 1 over 4 into root 2 minus root 6. And all that we did was to implement these trigonometric identities that we have here alongside the special angles table. Let's take more examples on this concept to establish understanding.